This is from having frustration with a gap between seeing that there are responsiveness issues and reflecting it with things like INP, and being actually able to act on them and fix them and understand why they happen. When I started this, I was looking at what we say about INP, and we were telling people, okay, look at your long tasks, check your long tasks, look at your TPT, and try to break long tasks so that your INP is better. And then I tried myself to use long tasks, and I found that they actually don't give you enough information. And they just tell you that there are long tasks. And the other thing I found is that long tasks don't actually measure all the things that happen. In the standard, long tasks happen when you start a task and until the point you start rendering. In the implementation of Chromium, which is the only living implementation of long tasks, also updating the rendering is its own task. So actually, if you have like something very long going on in a fetch response handling, and then you request an animation frame and do another very long thing, those would be two separate long tasks. And if both of them are, let's say, 30 milliseconds, then neither would be a long task, even though you blocked rendering for 50 or for 60. Another thing that I found odd is that in the standard, UI events are not actually specified in terms of tasks. It just hand wave to say when somebody pushes the mouse button, there should be an event sent at some point. It says nowhere how this works with tasks, etc. And what I found is that tasks are actually something very implementation specific. Not just that, but we changed the meaning of it in Chrome several times since long tasks came out. So we had several breakage to what you would see in long tasks and to what you would see in TTI and TBT, which are lighthouse metrics that rely on long tasks. So those just arbitrarily changed several times. Also, there are long tasks that exist, but we don't measure in long tasks just because of bugs, like promise resolvers. But that's kind of a different issues. So, yeah, that's why I was looking at what we should actually be measuring. And I came up with this long animation frame. There are actually older proposals that I was building on for long frames and for long task attribution from Nicolas and the previous people on the team. This is kind of a revamp. So the idea is, first of all, to test something that's meaningful to what can block user interaction, which is in this case from the beginning of a task until the frame is fully rendered. There could be usually one or two tasks there. There could be more depending on how the scheduler works, but in general, it's about one or two tasks. In Chromium, it could be 3. But the idea is that from the minute it's idle until the user agent is ready to paint, and that would be a long animation frame. So if you split your work between a set timeout and the subsequent request animation frame, it would appear as one long thing, etc. The other big change or addition is script entry points. So you can also see that in Explainer. The idea is that in addition to showing you that there were long animation frames, we show you a list of long scripts. Right now, a long script is 5 milliseconds or more, might be 10 or a different number. We'll have to play with the magic number there. Of the scripts that were there in the long animation frame, the source of the scripts, perhaps the line and column number, where it came from, like is it an event handler, is it a promise resolver, is it a user callback like who gets animation frame or set timeout, is it an actual script block like a script element or an import. There are other script entry points like the script URLs and other things that are not that much in use, but the idea is to focus on the script entry points, which are usually the highest cause of long main thread usage. And yeah. And in addition, give some information about whether some of the scripts cause layout crashing, like forced style and layouts, and give information about how much time was spent in style and rendering, in style and layout, and perhaps additional color like did it actually block an event? And this can and the correlation with the NPN with event timing. How long till presentation till the frame was actually presented on the pixel on screen, what we call, which is a flaky term, but like we can give some indication of that. Anyway, that's about it. And any question? I hope to start the demo. But I kind of fudged it.
Just let me stop the recording and we can